Bypass proprietary drivers. Direct Ethernet IP communication is faster and simpler for data acquisition layers. Pylogix uses the Common Industrial Protocol natively. To begin, instantiate the PLC object from the pylogix.plc class. Specify the controller IP address and the processor slot number, typically 0 for L7X or L8X controllers. This object manages the session state and connection pooling. The key advantage is eliminating licensing overhead associated with traditional SCADA integration methods. This direct approach minimizes latency, crucial for high-frequency data logging or real-time dashboard updates. We will focus exclusively on the methods required to extract and manipulate tag data structures. Python version 3.7 or higher is required for stable Pylogix operation. Install the library using pip install Pylogix. No external C libraries or compiled dependencies are necessary, simplifying deployment in containerized environments. Verify the installation by importing the PLC class. From Pylogix, import PLC. Ensure the host machine running the Python script has network visibility to the ControlLogix processor on TCP port 44818, the standard CIP port. Firewall rules must permit outbound traffic on this port. If using a virtual environment, activate it before installation to isolate dependencies from the system Python installation. Use a context manager for robust connection handling. The with PLC, controller IP, as com syntax automatically handles connection establishment and ensures proper session closure, preventing resource leaks on the PLC side. If the processor is in slot 1, specify processor slot equals 1 during instantiation. Connection attempts timeout after 5 seconds by default. Adjust this using the timeout parameter if network latency is high. Successful instantiation does not guarantee communication. The first read operation confirms connectivity. Always check the status attribute of the response object for connection errors before processing data.
Reading a single tag uses the read method, passing the tag name as a string argument. For example, response equals com.read motor_speed_real. The response object contains 3 attributes: value, status, and tag name. The value attribute holds the native Python type corresponding to the PLC data type. Double integer becomes an integer, real becomes a float, and Boolean becomes a Boolean. A successful read returns a status of 0. If the tag does not exist, the status code will indicate a tag not found error, typically status code 6. Always validate the status before attempting to use the returned value to prevent runtime exceptions in the application layer. Minimize network round trips by grouping tag reads. Pass a list of tag names to the read method for bulk retrieval. Tag list equals tag A, tag B, tag C. The response object will be a list of individual response objects, one for each requested tag, maintaining the order of the input list. This method significantly reduces latency compared to iterating through the list and executing separate read calls. For optimal performance, group tags that reside in the same memory bank or program scope. Avoid mixing program-scoped tags and controller-scoped tags in the same bulk request if possible, although Pylogix handles this transparently. Accessing elements within a user-defined type requires dot notation in the tag name string. If a structure named valve_control contains a double integer member named position, the access string is valve_control.position. Pylogix returns the entire user-defined type as a dictionary if the parent tag name is requested without a member suffix. The dictionary keys correspond exactly to the member names defined in the ControlLogix structure. This dictionary structure simplifies serialization into JSON or database records. Remember that array indices are specified using square brackets, such as array data, 5.
Robust industrial applications must handle non-zero status codes. Status code 1 indicates a general communication failure, often related to network connectivity or session timeout. Status code 6, the most common application error, signifies an invalid tag name or scope mismatch. Implement a dictionary lookup mapping status codes to descriptive error messages for logging purposes. If a bulk read fails partially, iterate through the response list and check the status of each individual item. Only tags with status 0 should proceed to the data processing pipeline. Use the write method to send data back to the controller. The method requires the tag name and the value to be written. Ensure the Python data type matches the PLC tag type precisely. writing a float to a double integer tag will result in a type mismatch error status. For example, to set a Boolean tag named start_sequence to true, use com.write start_sequence, true. Writing to array elements or user-defined type members follows the same dot notation and bracket syntax used for reading. Always verify the write operation status before assuming the PLC received the command. Optimize read cycles by minimizing the number of distinct CIP requests. If reading 100 tags, a single bulk read is vastly superior to 100 individual reads. For high-speed data acquisition, consider increasing the PLC connection buffer size if the controller load permits. Pylogix defaults to reading the maximum number of tags per request allowed by the CIP protocol, typically around 120 elements, before segmenting the request internally. Monitor the round-trip time using Python's time module to benchmark performance improvements after tag grouping adjustments.
Once data is retrieved and validated, the next step is integration. Convert the Pylogix response dictionary into a standardized format, such as a pandas data frame or a JSON payload. For time series data logging, append a high-resolution timestamp immediately upon successful read completion. This data structure is then ready for insertion into a PostgreSQL database using Sysocop, or transmission to a message broker like Kafka for stream processing. Decoupling the data acquisition layer from the visualization layer ensures scalability and fault tolerance in the overall industrial Internet of Things architecture.